Among all the stars that fill the southern sky, few inspire as much curiosity as Alpha Centauri. Not because of mythology or brightness, though it is one of the most brilliant stars we can see, but because of something much more profound. It is the closest sun-like star to Earth. For decades, astronomers have wondered whether planets orbit this system. Proxima Centauri, the faint red dwarf that completes the Trinity, already hosts several known exoplanets. But the central question has always remained: could a planet exist around Alpha Centauri A or B, the two stars that most resemble our Sun? Today, thanks to the James Webb Space Telescope, the answer may finally be within reach. In mid-2024, Webb's scientists focused on Alpha Centauri using the MIRI instrument, operating in the mid-infrared. To search for planets, they employed a coronagraph, a device designed to block the overwhelming brightness of a star. The goal was ambitious: to directly image a planet around the nearest Sun-like system, and during one of the observations, a faint point of light emerged, barely visible but unmistakable, a candidate planet sitting just outside the glare of the star. The team approached the detection with caution. Direct imaging of exoplanets is exceedingly rare, yet the signal behaved consistently enough to warrant serious attention. If confirmed, this world would become the closest known planet orbiting a star like the Sun, one of the nearest exoplanets ever directly photographed, and a milestone for the next era of planetary exploration. But soon, a puzzle appeared. When Webb revisited the system in February 2025, the planet was gone. Again in April, nothing. The same region, the same star, the same instrument. Why would the object appear once, only to vanish later? The explanation may lie in its orbit. Simulations showed that, in nearly half of all plausible orbital configurations, the planet would move so close to the star that the coronagraph would simply hide it from Webb's view. In other words, the disappearance is not evidence against the planet. It is consistent with its expected motion. The planet may still be there, temporarily engulfed by starlight. Direct imaging is the most challenging method in exoplanet science. It requires overcoming several obstacles at once. Stars are overwhelmingly brighter than the planets around them. The signal of a planet is faint and easily lost in noise. Optical reflections and instrumental artifacts must be filtered out. Precise alignment is needed to suppress starlight. Alpha Centauri adds further complications. It is the third brightest star in the night sky. Its companion star, Alpha Centauri b, shines nearby and introduces additional glare. The planet, if real, reflects very little light and requires advanced filtering to extract its signature. To reveal the candidate, researchers had to block the star's core brightness, remove as much noise as possible, enhance the faint, consistent detail that remained, test the result across multiple reduction techniques. The final processed images revealed the same dim point, exactly where a planet should be. One of the most intriguing aspects of this discovery is the proposed location of the planet. Models suggest that it orbits within the habitable zone of Alpha Centauri A, the region where temperatures allow liquid water to exist on a surface. However, the planet itself does not appear to be Earth-like. Current interpretations indicate a gas giant, more comparable to Jupiter or Saturn than to a rocky world. Such a planet would not host life as we know it, but it could have moons with environments worth studying. Even so, the discovery would still be extraordinary. It would be the nearest gas giant candidate orbiting a sun-like star, the closest such world ever directly imaged, and a potential stepping stone toward future exploration of the Alpha Centauri system. Alpha Centauri is often simplified as a single bright point in the sky, but it is actually a complex triple star system. Alpha Centauri A, slightly larger and brighter than the Sun Alpha Centauri b, slightly smaller and cooler Proxima Centauri, a distant red dwarf orbiting the pair. Planets around Proxima are already known, including one in the habitable zone. But planets around Alpha Centauri A or B have remained elusive, until now. If Webb's detection holds, this would fill a long-standing gap and confirm what astronomers suspected for decades. Even our nearest stellar neighbors may host diverse and dynamic planetary systems. Despite the excitement, science demands evidence repeated through time. Confirming this exoplanet will require new observation campaigns, different orbital phases, improved coronagraph alignment, cross-checks with ground-based telescopes, elimination of all known instrumental artifacts. The research team emphasizes that the absence of the planet in later observations does not weaken the detection. It simply highlights the reality of orbital movement and the limitations of current imaging techniques. Future observations will determine whether this point of light is truly a neighboring world or a transient signal yet to be understood. If this discovery is confirmed, Alpha Centauri will become an even more compelling target for future missions. Planned interferometers. Next-generation coronagraphs telescopes designed specifically to image Earth-like worlds, potential robotic probes in the coming decades. A gas giant in the habitable zone may not host life, but its presence suggests that smaller worlds could exist in the same system waiting to be discovered. For astronomers, this is only the beginning. The James Webb Telescope may have revealed one of the most significant exoplanet discoveries of our time, a gas giant orbiting Alpha Centauri A, the closest sun-like star to our own. Whether this world is truly there or merely a glimpse of something more complex, the search continues. Each observation brings us closer, not just to understanding a single planet, but to answering one of humanity's oldest questions: what lies around the stars nearest to us? And if this discovery holds true, then the nearest planetary neighbor of a sun-like star is not a concept of science fiction. It is a real world orbiting just 4.3 light-years away.